So we're going to do some basic introduction to functions today. But first, before we start into functions, we have to talk about what a relation is. And all a relation is just a set of ordered pairs. And ordered pairs are just like you would think of coordinate points in a plane. And it can be connected, it can just be dots. It's just kind of a very loose term for set of ordered pairs. Okay, domain is called your input values. It's called your independent variable. And most typically, unless we have different variables we're using, these are going to be the x values on your graph. Your range is going to be your output values. These are dependent on the domain, so they're called the dependent variable. And then these are going to be your y values. All right, so we're just going to talk about some different ways that we can display domain and range. And so I just have actually a relation here. So it's a set of ordered pairs, and it says identify the domain and range, and then we want to graph. So I'm going to pause my video real quick and graph. So I just plotted the points. The domain, what we want to do is list the x values, and they don't have to come in any particular order. I'm just going to list them as the points appear here, and each one of these is different. If any of these values repeats, then you only need to list it once. And then my range, I'm going to list the y values of each of the points. And each of those is different as well. And then we're going to talk about what is a function. Okay, so a function is a relation where every x value has only one y value. So if you're a function, every x value can only have its own y value. It can't have multiple y values. So basically what this means is no x value repeats, is how I want to remember that. I can't have two different x values that are, or I can't have two x values that are repeated, so I can't use the number twice. It's totally fine to have repeated y values, but not repeated x values. And to check this, the easiest thing I can tell you to do to check if something is a function is, does it pass the vertical line test? So the vertical line test is literally I usually just slide my pen or pencil across the graph, but literally to draw vertical lines. And any vertical line touches only one point on the graph. And if that's the case, then that graph passes the vertical line test and it's a function. If it fails the vertical line test, then it won't be a function. So like if I come up here to the graph we just put on here, if I'm sliding my pen or pencil or whatever across and thinking about any vertical line I could draw, or I could actually like grab something, draw vertical lines here, like here, just here are the points on the graph. I only ever touched one point each time I did that. So if I only ever touch one point, then that means this that we just graphed, this is going to be a function. All right, so we're going to use the vertical line test here as we go down. So the next example, I actually already have points plotted on the graph. And then the first question is this a function? So again, you could slide your pen or pencil across, however you want to do this. Draw vertical lines in. If I do this, I'm only touching one point. Now here, if you guys see this, this is a problem because here I'm touching two different points with this vertical line here. So this guy is not a function because it's going to fail the vertical line test here. Oh, I guess I could have written that there. This relation does not represent a function. Now, just because it's not a function doesn't mean we can't identify the domain and range. So domain here, I'm just going to go across the graph and grab the x values. So like here I've got an x value -4, Here the x value is 0. Here the x value is 2. This one's 3. And then I have 5 on 2 different points, but I only have to write it once. Okay, so I'm just writing the x coordinates there. Now the range, I'm going to go the other direction and write the y coordinates. Again, if any of them repeat, you don't have to write them twice. So here I have -4, but it appears in 2 different points. I just need to write it once. Let's see, this one, the y coordinate is going to be 0. This one, the y coordinate is going to be 2. And this one up here, these both share a y coordinate of 4. So if anything repeats, you just write it one time. You just need to represent it, not write it multiple times. And then at the bottom of the page here, instead of having points, I have graphs that are continuous. So we're just going to go through. I'm going to slide this, and this would be true for any, we've got a parabola here, any quadratic. Here, if I'm drawing vertical lines, I'm only ever touching one point. If I drew, if I'm drawing in vertical lines, and I know it gets kind of steep, but you're only ever touching one point with any vertical line on a parabola. So this is a function. And then for the domain, even though it points down, it does go to the left forever, it goes to the right forever. So -infinity to infinity here. Now the range, remember the range go from the bottom to the top. This is pointed down forever. So I got to start my interval at -infinity. And as I'm tracing here, the graph does stop, and I don't have any graph above this point right here, and I want to pick off the y value. So that point right there is 0, 5. So the last y value I touch is 5, and that's going to have a bracket on it. Now, the next question, this is circle, and then obviously this fails the vertical line test in like a million different places. I'm touching 2 points on pretty much almost any vertical line that I draw, except I could draw a tangent line here, but we're getting into that later. Anyway, this miserably fails the vertical line test, so this is not a function, but that doesn't mean we can't do domain and range. So I'm not touching any part of the circle till I get to this point right here, which is -5. Now, I'm continuously touching points on this graph as I slide my pen over here. The last x value I touch is going to be right here, and there's no more circle over to the side. And so my last x value is going to be 5. Now, because this is a circle and it's centered at 0, 0, the range is actually going to be the same. So the first y value you touch from the bottom of the graph is going to be -5. And then the last y value you touch up here is going to be +5. And then finally, I just have an example that's a line. So this, we're good to go. We're passing the vertical line test at every place. So this is a function. Any line is going to be a function. And actually the domain and range is the same for any line, doesn't matter what the slope is, except for a vertical line. That is the only situation that this wouldn't work for. And a vertical line wouldn't be a function because it would fail the vertical line test. But any line that's not vertical has a domain left forever, right forever, so -infinity to infinity. For the range, this side goes down forever, this side goes up forever, so also -infinity to infinity. Another way to display functions and relations is called a mapping diagram. So just to go through this real quick, these are relations. I don't know exactly if it's a function or not. We're going to decide that, and I'm going to show you how to do that visually through these mapping diagrams. What you want to do when you draw a mapping diagram, the domain is going to go on the left side, and it doesn't have to be that particular shape. It could be a rectangle or a circle or whatever. You're going to list the domain values in the first box, and you're going to list the range values in the second box. Remember, if anything repeats, you only have to write it once. So I'm going to write my x values here. I've got 2 again, so I don't have to write it a second time, -3, -4. And then again, doesn't matter the order, I'm going to list the range values. I have 3, I have 5, I have 7, and I have 9. Each of these is different. All right, the way the mapping diagram works is you draw an arrow from the domain value to its matching range value. So always points here to the right. So 2 goes with 3. The next point is 2, 5. The next point is negative 3, 7. And the final point is negative 4, 9. Now, what you're looking for here is visually, if you didn't have a list of the points, if you're just looking at the mapping diagram, is this a function or not? This guy, definitely not. What you're looking for is 2 or more arrows from the same domain value, which I have there with the 2. That's going to be a no, because if I've got multiple arrows coming out of the same domain value, that means that X value was repeated. And maybe you could just notice that right up here, like here I had 2 and then 2 was repeated. If any of the X values repeat, that is a problem and it will fail the vertical line test. If I had those 2 points on a graph, a vertical line would touch both of them and then I'm failing the vertical line test. Okay, domain and range here. Same thing, I'm just going to write down the X coordinates. Looks like we just have 1, 2, 3, and 4. And the Y coordinates, I have 3, 3 again. Then I have 5 and 5 again. All right, and then I'm just going to draw my map. So the X coordinate of 1 goes with 3. 2 also goes with 3. 3 goes to 5, and 4 also goes to 5. Now here, as long as you just have one arrow coming out of each of those X values, this is going to be a function. This is not a problem for the vertical line test. If you were to plot these points on a graph, they would pass, and we don't have any X values repeated. It's completely fine for the Y values to repeat. All right. Now, after we're done domain range here, we're going to kind of get in a little bit of an introduction to some function notation. So I just want to write down here, function rule, function notation. You guys, I'm just going to make something up. Let's say we have y equals 1/2 x plus 4. So just the equation like an mx plus b, just a line. Okay, a function notation is just going to switch that up a little bit. And usually they start with x, but f, but sometimes they use like a g or an h or something like that. But this exact equation in function notation would just look like this. And basically it's saying it's a function of x. This is read f of x. The idea behind this is what I'm doing is I'm plugging x in. This would be my function rule here, this 1/2 x plus 4 that I made up. I am plugging in something for x, and whatever I get out here, as you guys are used to thinking about it, it would be the y value. Here, it will just tell me I plugged in this number, and then we'll evaluate to see what we got. So it's very similar to what you're used to. It's just a little bit different notation. So this just says convert this to function notation in the next example. So literally all I have to do is do f of x equals 9x plus 2. That's it. Now, if you don't have y by itself, like I have in this next example, we'll need to do that first real quick. Just use a little algebra. Let me move that negative 2x and slide that 8 down. We're going to divide everybody by 4. And simplify here. So this would be y equals negative 1/2 x plus 2. And then all I would have to do to convert that to function notation real quick would just do f of x negative 1/2 x plus 2. So it does have to be set up so you have all the operations on your x on one side of the equation, and then you can replace that notation. Now, the last thing we're going to do here is just a little evaluation. So if I'm going to evaluate a function rule, so here's my function rule, f of x equals 3x minus 5, and it's going to ask us to find f of negative 4, f of 0, f of 8. Okay, literally all this means is we're going to plug in that number for x. Now, what you got to remember here, f, it's not a variable, it's just notation, so don't even touch the left side of that equation. I would not even touch it. This, you're just going to simplify the right side. Your input value is the negative 4, and my output is going to be what I get when I evaluate that, which is going to be negative 17. So f of negative 4 is negative 17. What that really means, like if I were to put this on a graph, this is the point negative 4, negative 17. The notation is just telling you this is the number I plugged in, and the evaluation is saying this is the number I got out. So this is your input, this is your output. So each of these, I'm literally just replacing 0 with the number that I see. This would be 0 minus 5, so negative 5. Sorry, back here, the negative 17 is my answer. The negative 5 is my answer. I was just trying to relate that for you guys. This last one, we're going to plug in 8. I don't know why I put an extra parenthesis there, sorry. This is going to be 24 minus 5, so this will be 19. So if I plug in 8, I get out 19. It would correspond to the point 8, 19. This would correspond to the point 0, negative 5 if we were putting this on a graph. Okay, and then finally down here, sometimes we use different functions within the same problem. So you'll see I have f of x, I have a g of x, I have an h of x. Sometimes you'll see a j of x. It's just different letters to indicate we're using different functions. So for my little example here, I need to do h of 2. So I'm just going to do that first real quick. Just come up here and make sure you pick the correct function. So h of 2, this is going to be 6 plus 6, which is 12. I need to do g of 3. So the g function's in the middle there, negative 10. We're going to plug in 3 there. So this is going to be, let's say, negative 34. And there's a 2 in front here. Let me show you how to deal with that in a second. But what I need to figure out is what f of 4 is. So here's f of x. So this is just going to be 4 plus 2. So this is 6. So then I'm going to just back up and plug these lovely numbers in. So h of 2 is 12. G of 3, now this is a little tricky, is negative 34. And then plus 2 times f of 4 should be plus 2 times 6. All right, so what do we got here? I've got 12 minus a negative 34, so it'd be 12. Here, I'm going to write it down here. This is going to be 12 plus 34, and then 2 times 6 is 12, so plus 12. So we're just going to add those numbers up to get our final answer. So it should be 58 when you add that all together. And then I've got just another quick example. This is a little different. It's got some division. I still need to find f of 3. So it's going to be 3 plus 2, which is going to be 5. I need to find g of 5, which is negative 10 times 5 minus 4. So negative 54 there. And then I need to have h of 1, which is going to be 3 times 1 plus 6. So we're going to get 9. And then I'm going to plug these in. So the top of the fraction is going to be 5. Now, when you do this problem, the bottom of the fraction, it acts kind of like parentheses. You need to simplify the bottom before we do the division here. So this is going to be negative 54 plus 9. So don't do the division. We want to simplify the bottom first. Negative 54 plus 9 is going to be, let's see, negative 45. And then here, if you can, which we can here, this can be reduced. This is going to be 1/9 as my final answer. So there we're just evaluating the function.